Okay, good morning, students. Today we are just continuing the unit 3, and our topic was atomic radius, and we have discussed the types of atomic radii. First was the covalent radius, second was the van der Waals radius, and third was the metallic radius. Now, students, these radius when they are just studied about their variation across the period and down the group, we found that when moving across the period, the atomic radii or the atomic size is going to decrease from group 1 to group 17, and moving down the group, the atomic radius increases. Now students, today we are going to discuss about the ionic radius. Now, what is an ionic radius? Before that, we have to go through it, how the ions are being formed. Now, in a neutral atom, by losing or gaining an electron, an ion is formed. If a neutral atom loses an electron, it will form a cation. And if it will accept an electron, it will form an anion. Now students, when the two oppositely charged ions, that is the cation and the anion, they will come closer. A bond is formed which is known as the ionic bond. So here the ionic bond is formed by the lose or gain of the electrons. Now students, the ionic radius, it is actually, we can say, the internuclear distance between the two ions, right? We have to first find out the internuclear distance between the two ions, and then we are going to just sum up that to be radii of cation plus radii of anion. Now, when we are going to define it, we will define it as the, we can say the distance or the effective distance till where the nuclear charge influence of an ion is going to execute in a ionic bond. So students, I have written a definition on the board. You can have a just view on it. So ionic radius, it is the effective distance from the nucleus of the ion to the point up to which it has an influence in an ionic bond. Now when we say it has an influence, it means that if it is a positive charge or a cation, it will have its attraction, right, for the negatively charged ion. Similarly, a negative charge ion will have the attraction for the positive charge ion. So their effect, okay, how long their effect is going to execute or is going to work, right, from the nucleus of it, right, will be known as the ionic radius. Now, if we consider this as a cation, right, students? So here let it be A plus. This is a cation, and this is an anion, right? Now, this is the nucleus of their, we can say, the atom, or now they are the ions, right? Now, the influence of it. So, this part will be known as cationic radius, and similarly, this part, we can say, this one will be known as the anionic radius. Right, student? And the sum of these two, R plus and R negative, is known as the interionic distance. So interionic distance between these cation and anion is R plus R negative. Right, student? So the ionic radius, it is the, we can say, the distance from the nucleus of the ion to the point up to which it has an influence in an ionic bond. Right, students? So it is clear to you. So what will be the cationic radius? The cation, that is the ionic radius of an cation, is known as cationic radius, and the ionic radius of an anion will be known as the anionic radius. And the interionic distance between the two ions is uh, calculated or is we can say observed through the X-ray diffraction studies. Now students, we are going to compare the size of the cation and with its parent atom, and the size of the anion with its parent atom. Right students, so we will do it. First we will just check that the size of the cation and the size of the parent atom. Now, for that, let us take an example of sodium. So, sodium, right? So, what is the configuration of it? It is 11 atomic number. So, we will have it 1s2, 2s2, 2p6, 3s1, or we can simply write it as a 281 configuration, right? So, it has got a configuration of 281. Now, when it loses an electron, now here student, Na is losing an electron and it is forming Na plus. Now, the electronic configuration changes from 281 to 28. That means the electronic configuration, we are talking about electronic configuration here. The species will remain the sodium only, the sodium ion. Right, so here the sodium is the parent atom and this is a cation which has been formed. Now students, we are discussing here, or we are going to compare the size of the cation to that of the parent atom. Now it has been found that the size of cation is smaller than parent atom. So size of cation is smaller than the parent atom. Now students, if you see here that what's the difference here? The number of the protons in sodium is 11 and that of the proton in the sodium ion will be also 11 only, right? Only difference is that here the number of electrons in sodium, is parent atom, it is 11 and here it is 10. So we can say that here the in sodium in the parent atom 11 protons are pulling the 11 electrons to it, right? Whereas in sodium ion, the 11 protons are pulling the 10 electrons. So here students, 11 protons are pulling the 10 electrons, and here students, it is 11 protons pulling the 11 electrons. So tell me, where is the magnitude of nuclear charge will be more? Or we can say the effective nuclear charge which will be getting applied on the electrons, right, will be more in sodium ion. So we can say that if the nuclear charge, effective nuclear charge is more, then the size is going to shrink, and hence the size of the cation is smaller than that of the parent atom. So students, the size of cation is smaller than parent atom. Why? Because the effective nuclear charge on the cation is greater than the parent atom. Therefore, the outermost electrons are pulled more inside in cation. Hence, the size of cation is smaller than the parent atom. Right? Now, we will just go through the second part of it, that is the size of the anion is bigger than that of the parent atom. So students, let us take an example first. Let it be chlorine atom. It's a neutral atom, and you know its configuration is 287. You can write down the configuration in the term of shells and subshells also, right? And the orbitals. So chlorine accepting one electron and it is changing into chloride ion. Now when it does so, here the configuration of electron is now 288. Now students, here you will see that 17 protons are pulling 17 electrons. But in this case, here the 17 protons are pulling how many electrons, students? 18 electrons. Now, where do you think the magnitude of the nuclear charge? Right, we can say that the effective nuclear charge, where it will be more? It will be more here. Here it is going to be less because 17 protons are pulling 18 electrons. So definitely magnitude of the effective nuclear charge will be less here, right? And here it is going to be more. So that's why the size of the parent atom, this is the parent atom and this is the anion which is formed, right? So if we just compare the size, so size of parent atom will be smaller than the size of anion. So we can just write here now that the size of anion is larger than parent atom. Now here it is why? Because the effective nuclear charge on the anion, so because the effective nuclear charge on the anion is less or lesser than parent atom, therefore the outermost electrons are less effectively pulled inside, hence size of parent atom is smaller. Right students, so size of anion is larger than the parent atom. Why is it so? Because the effective nuclear charge in the anion is lesser than the parent atom, right? The effective nuclear charge. So here you can see that so 18 electrons have been pulled by the 17 protons. So here the nuclear charge which is operating on the 18 electron will be lesser in comparison to that of the parent atom. So the parent atom, in parent atom, the outermost electrons will be pulled inside more strongly, right? And hence they are going to be smaller. Whereas in case of anion, the size is going to be more.